So I told you the physical properties of alkene, that was same as alkane, like as the number of carbon increases, so the melting and boiling point increases. As the number of carbon increases, so the solidity increases, and you can say the density increases, or you can say the volatility decreases, and you can say insoluble in water. So as the number of carbon as the number of carbon increases, so the volatility. Can you tell me what is meant by the term volatility decreases? Yes, volatility.
So volatility um is like when the it was volatility decreases means basically the change is starting to decrease. The sudden change um decreases. Oh no, sorry. I got confused. I think it's volatility is when a substance is
Evaporate
ready
at a room temperature.
that
Exactly.
vaporizes, yeah.
Evaporate at room temperature. So
Yeah.
let's suppose we have two compounds. First one is propene, and the next one is hexene. So can you tell me which one is more volatile and which one is the less volatile? Yes.
Propane and what? Propane and hexene.
Yes.
Um,
So which is more and which is less
More
volatile?
volatile.
Yes.
Give me a second so to think. Volatility. Propane and hexene. So propane would be more volatile, right?
Why?
Because propane is C3 H6, right? And
Okay, yes.
hexene is C6 H12, right?
Okay.
And volatility only increases with smaller molecules.
So basically, it has more atoms, less atoms, strong intermolecular force, weak intermolecular force. So that's why this is less volatile, and this is more volatile. Okay. Hmm? Are you
Yeah,
getting
I
my
understand.
point? Okay.
Yeah.
Okay. So chemical properties. You can also do combustion reaction for alkene, and generally remember that alkenes are more reactive than alkane. It has double bond, and alkene is unsaturated hydrocarbon in which there is double covalent bond between carbons. Okay, so combustion is the first reaction. What is combustion reaction? Hmm?
What is what?
Combustion reaction.
Combustion reaction. Combustion
Hmm?
reaction is like a chemical reaction between uh, with oxygen present that produces light and heat.
You can say this is burning, right? You can say this
Yeah,
is
the
burning.
burning in the presence of oxygen.
Yes, in the presence of oxygen. In the last class, when we were discussing cracking, so we were also providing some heat, like we were giving the higher temperature. So what is the difference between cracking and combustion?
Between
And
cracking and
also,
combustion.
yes, exactly. And also, like in the cracking, we have anaerobic condition.
Have what?
What is anaerobic condition?
Anaerobic condition is when oxygen isn't present.
Good. Oxygen is absent. Air is absent. If in cracking you are going to give oxygen, you are going to provide, you can say, air. So, so rather than cracking, the compound would be combusted. It would be giving you the oxide. I don't want to have oxides of elements. Like I don't want to have carbon or di or monoxide. And I don't want to have like the water that is the oxide of hydrogen. To avoid combustion, to avoid combustion, we must not have oxygen in the reaction environment. So in a combustion reaction, big oxygen is needed. So uh, this is the difference between combustion and, you can say, cracking. So let's suppose we have ethene. Starting from ethene, this is C2H4, C2H4, C3H6, C3H6, C4H8, C4H8, C5H10, and C5H10. And you know the general formula for alkene is CnH2n plus 2. The general formula for alkene is CnH2n only. Like the number of hydrogens are double than that of the carbon atom. If you can see, if the carbon is n, so the hydrogen is 2n. If the carbon is 6, so the hydrogen would be 12. If the carbon is 4, so the hydrogen would be like 8. So the first one is complete combustion, and the next one is incomplete combustion. Then complete, then incomplete, then complete, then incomplete. Okay, that's why I have written twice of the same compound. They all are going to react with oxygen, obviously. Yes. Can you tell me the product and also the balanced chemical equation?
The product and the balanced chemical equation. Okay. So for C₂H₄, it'll give us CO2 plus H2O, but it'll be 2 CO2 plus H2O. And for C, so
Carbon dioxide for complete combustion, carbon monoxide for incomplete combustion, and also the water. So if you are going to balance this, would be 2, it would be 2, would be 2, it would be 2. So for oxygens, 2 into 2 is 4 plus 2 is 6. So there should be 3. And 2 and then 2, 4, it should be 2. Got it?
yeah.
Same goes with all. Okay.
It'll be the complete reaction. So it'll be C3H6 plus 5O2 gives us 3CO2 plus 3H2O.
Mhm.
And for the incomplete one, we have to write 5O2
You,
gives us,
you were saying this is 5O2, right?
yeah.
5 to the 10, 3 to the 6 plus 3. 6 plus 3 is 9, not 10.
Huh? Wait, I think I did something.
Should be 9 upon 2.
Yeah. And for the half reaction, everything stays the same except the number of oxygens in CO. Three CO.
CO and H2O. And how many oxygens?
9.5. No, sorry,
3.
9.5. 3, yeah, because there's only the
Yes.
four C. It's gonna be 4 CO2 plus 4 H2O.
Then 5.
Okay, for 5, it'll be 5 CO2 plus 5 H2O. And there'll be 8 oxygen. No, 15 oxygen, I think.
So should be 5. Yes. Now it should be 5.
Yeah.
Yes. So 5 into 2 was 10 plus 5, 15. So 15 by 2.
Yeah.
Okay. Okay, then we have addition reaction. So addition means, let's suppose this is an alkene. Let's suppose carbon is double bonded, and this is the simplest alkene, that is ethene. It's going to react with AB.
Mm-hmm.
It's going to react with AB. So let's suppose this is formed. There is one technical error in this compound. Can you tell me what's the problem with this structure?
What's the problem with this structure? Hmm. Like, what did you do to the structure? I don't get that.
Like I told you, the valency of carbon, that is equal to 4. That is equal to 4. So how many carbon, like how many bonds are there in this structure with carbon? If you can count, this is 1, this is 2, this is
Yeah,
3, this is 4,
three,
this is 5.
four. Yeah, there's too many bonds with carbon. There's five
Exactly.
bonds with
It
carbon.
should be
Carbon
removed.
only bonds with 4.
Exactly. It should be removed so that it can add on this double bonded carbon atoms in alkene. So remember, in any addition reaction, the double bond should be removed. Like the alkene is going to convert into alkane. So basically, in any addition reaction, alkene would be converting into an alkane. In any chemical reaction, like in any addition reaction, basically. Let's suppose, uh, we have the first reaction, that is, you can say hydrogenation. Hydrogenation. So hydrogenation means that addition of hydrogen.
All right.
Addition of hydrogen, for this, we have certain conditions. Like this reaction doesn't happen at a normal condition, you can say at a normal temperature and pressure. There should be 200 degrees Celsius temperature. Okay. And there should be a catalyst, that is a nickel catalyst. That is a temperature. Okay. So this is a
Yeah.
catalyst. So we always use a catalyst basically. Like, can you tell me the definition of catalyst?
It speeds up the rate of reaction.
Okay, and decreases the activation energy, right?
Yes, without getting used in the reaction.
Exactly, and it provides alternative pathway. It provides alternative pathway basically. Okay, so then if you have this like such condition, so you can also use palladium catalyst, like in hydrogenation. This can be used in like hydrogenation. And then let's suppose this is your alkene, this is your ethene. It's going to react with this hydrogen in the presence of nickel. So alkene would be converting into alkane.
All right.
These are the extra hydrogens. Okay.
Yeah.
Let's suppose I have this propene and hydrogen is added into propene. So it's going to convert into propane. Can you draw the structure when the propene is going to convert into the propane?
Um. Okay. All right. Give me 1 second. Let me draw it.
Mhm.
What's up to send the picture? So can you show me and I'll mark it.
Should I make you admin,
No,
like
it's okay.
host?
It'll take too long.
Okay, yes. Are you going to send me, right?
No, I can't.
And also I'm doing just you can match. Just you can match. See
Alright.
this. This is propene. Yes, got it?
Yeah, I got the same answer.
Good. Okay, this is hydrogenation. This is what hydrogenation basically. Okay, so okay, when let's suppose if you see a question in which we would be asking like why this is an addition reaction, like how can you say that this is an addition reaction? Yes.
Yeah.
So what would you be writing? Let's suppose if he is asking like how can you say that this is an addition reaction? Yes.
How can we say that it's a addition
Addition reaction.
reaction?
Exactly. Hmm.
Um, okay, so we could say because it has a triple bond,
Hmm. Single
right?
bonded.
Oh, sorry,
Single,
single bond.
single, single,
No, no,
single,
no, no.
single, single.
Yeah. Is it
If
because it has three single bonds?
basically you're supposed to write because only one product is formed. Only, okay, only one product is formed.
Okay.
only one product, because there is no anything that is removed from the reaction mixture, because this is an addition reaction. This is not an elimination reaction, like something is going to be removed from the reaction mixture. No, because something is added. So added means what? There is no anything to eliminate from the reaction mixture. So nothing would be produced except only one
Mhm.
product. Are you getting my point?
Yeah.
Yes, exactly. So he would be giving you multiple like reactants, including propene, then butene, then pentene, then hexene, like so on. So you would be like writing accordingly. Okay, so this is an addition reaction, like hydrogenation reaction. And then another reaction we have, that is bromine, bromination.
Yeah. Okay.
Bromination means that it's addition of bromine, it's addition of bromine. So can you tell me the color of bromine?
The color of bromine. I think it was the color. It was like reddish brown.
Like reddish brown, exactly. So let's suppose when bromine is in this form, okay, so this is colored like reddish brown color.
Yeah.
And let's suppose when it's going to be added, when it's going to be added in an alkene, okay, whether
Yeah.
you have hexene, propene, ethene, butene, any alkene, so you will see that, let's suppose, um, this is ethene, it's going to be added. So you will see that I should remove one bond. Am I right?
Yeah.
Hmm. So this is called bromoethane. This is called 1, comma 2 dibromoethane. This is called 1, comma 2 dibromoethane. Okay. Or remember, when bromine is added in water, like I'm talking about bromine aqueous. I'm talking about bromine aqueous. So this would be orange in color. Okay. This would be
Yeah.
orange colored solution. So this would be orange colored solution basically. So, so, so bromine will decolorize in the presence of alkene. Bromine will decolorize in the presence of
What?
alkene. But when you are going to add bromine in an alkene, when you are going to add bromine in an alkane, like the single bonded one, so it's not going to react with alkane, because alkane doesn't show addition reaction. Alkane can only show substitution reaction that we did. So, so this is a good difference test between alkane and alkene. This is a good difference test between alkene and alkane. So when you are going to add bromine water in an alkene, so there is no change in color. So which shows that this is alkane. But when you are going to add bromine in an alkene, so which shows that like when the bromine is going to change its color, so it's mean that alkene is confirmed. Okay.
Okay.
See this. Okay, see this. Mhm, mhm. See this. Mhm. Okay, yes, alkane and alkene. So now they are
Yeah.
going to add
Okay.
bromine water in an
Yeah.
alkane. So you will see there is no change in color. Like the solution will be colored. This is the color of bromine. And bromine is
Yeah.
not going to be added in an alkane, so that's why there is no change. But when
Okay.
bromine
I
would be
understand.
added in alkene, so see this. Yes. See this. It's going to be colorless. See
Uh-huh.
this. Yes. So in this way, you can check whether the solution is of alkene or alkene by just adding the bromine water, or you can see the bromine solution. Okay.
Mm-hmm.
So in this way, you can like we always check. So this is a difference test between alkene and alkane. Differentiate between alkane and alkene. So we have, let's suppose this is sample X, and X may be any alkane and alkene, maybe. So I'm going to add bromine aqueous. I'm going to add bromine aqueous. So if bromine aqueous decolorizes, I mean to say orange to colorless, orange to colorless. So alkene is confirmed. But if so, alkene is confirmed. Okay, this is so simple.
Yeah.
And also, what if that I have propene, it's going to react with bromine, and it's going to give 1,2 dibromopropane. Just draw
Mm-hmm.
the structure and then send it to me fast. Same thing.
Yeah. Yeah, I got the
Okay.
same thing.
Same goes with chlorination, right? If the examiner is going to give
Yeah.
you chlorine, so it would remain the same. Bromine would remain the same. You would be writing down the same product. You would be
Yeah.
attaching at the same position. So this is all about addition reaction, but we have like few some other reactions as well. Okay, so basically alkene is you can say a large topic as compared to alkane, because in this we have different addition reactions, but in alkane we had no any addition reaction. We had some just like you can say substitution reaction. So we would be discussing hydration as well. We would be discussing how to add HCl or HBr, and also the H2O, and also how can we remove H2O, like an elimination reaction. After addition, we would be learning how to like eliminate a molecule from the compound, like what are the conditions that we are supposed to give. Okay, so we would be continuing like this is an alkene. So alkene has not finished so